Yeah, actually, first let me know in what field actually you have that exposure. Why? Because are you aware of I mean waterfall model or agile model?
ఏ మోడల్ అండి?
వాటర్ఫాల్ మోడల్, అజైల్ మోడల్ అంటే ఏం తెలుసా అండి? నో ప్రాబ్లం. మీరు ఇప్పుడు లినక్స్ మీద వర్క్ చేస్తున్నా అని చెప్పారు.
అవును.
ఓకే, ఓకే. టుడే ఐఎమ్ గోయింగ్ టు గివ్ ఇంట్రడక్షన్ టు ఫస్ట్ డెవాప్స్ అండ్ యాక్చువల్ గా మన వర్క్ ఏంటి యాజ్ ఎ డెవాప్స్ ఇంజనీర్, అది అసలు మనం ఎందుకు చేస్తాము, వాట్ ఈస్ ద రోల్, సో ఇది మనం ఎలా యాక్చువల్ చూద్దాము.
ఓకే,
రైట్. సో యాక్చువల్ గా ఓల్డెన్ డేస్ లో we used to have waterfall model అండి. సో కంప్లీట్ గా సాఫ్ట్వేర్ లైఫ్ సైకిల్ తీసుకుంటే, డెవలప్మెంట్ లైఫ్ సైకిల్ SDLC తీసుకుంటే, అర్లియర్ we used to have a waterfall model. సో వాటర్ఫాల్ మోడల్ అంటే ఏంటంటే, ఫర్ ఎగ్జాంపుల్ ఏదైనా సాఫ్ట్వేర్ డెవలప్ చేయాలి అంటే మనము ఫస్ట్ బేసిక్ స్టెప్ ఏం తీసుకుంటామండి? డిజైన్ చేస్తామండి. రైట్. డిజైన్ ఈస్ ద ఫస్ట్ స్టెప్, రైట్. సెకండ్ ఏం తీసుకుంటామండి మనము? డిజైన్ అంటే మనకి ఏంటి అంటే, సో వాట్ టు డెవలప్ అండ్ what is the requirement of the client. So this is the thing we are supposed to take. So once they are done with the design, so once the business meeting is done and after giving the requirement by the client, we'll come up with the design. So once design is done, we are going to develop the code. So the developer will develop the code. So it is develops the code. So until and unless the developer develops the code, so nothing is going to happen in the process. Right. So once the developer develops the code and the tester is going to test the code, so whether it is working under the particular environment or not, and that may be manual testing or that may be automation, and testing will be done. So once the testing will be done, the deployment is going to be happened. Deployment into the production environment. So here, this is the procedure we used to follow in the waterfall model. So what happened is, so there is a drawback in this model is, so once the client is giving the requirement, let us take, developer is taking the time around so maybe the tester, non-availability of the tester, and due to the delay by the tester, it may take around another 3 to 4 weeks. And even if it is done, for the deployment, we need to have some servers. For example, if you take a Facebook application, so for the Facebook application, after designing front-end and back-end applications, we are supposed to deploy in the server. And earlier days, we used to have physical servers. And now we are making use of clouds. So here, to deploy the application in the server in the sense some environment, physical environment. So we are deploying the server. So to deploy in the server, again, the team, operational team, the deployment will be taken by operational team. The operational team, first they need to produce some requirement for the servers, maybe with respect to configuration, with respect to the license permissions, and with respect to the number of servers, and everything must be approved by the higher authority. So it may get delayed. So once the design part is completed, and once the client requirement is done, to get it deployed, it is taking huge time, right? So by the time the deployment happens, the client may change. So the mindset of the client may change, and they used to deny the products. So for that, they have come up with the agile model. So in the agile model, the scenario is same. In the agile model, but here the same process will be done in repetitive modes, or I can say recursion. So here, let us take a 2 weeks time. So in the 2 weeks time, and first they'll design and code and test. And again, the client will come into the picture and he will check whether the requirement is met or not. And again, if he suggests any changes, again it is going to be designed, and they are going to come up with again design, and again they are going to test, and again they are going then to code, and again they are going to test, and again so the process will continue. So with this here, the client will be in touch, and the client requirements will be taken into consideration in the frequent intervals. So here the productivity is increased, and the time gap is also reduced for the deployment purpose. So here, this is about agile model. And even there is a gap in the agile model. So even it is taking much time for the deployment, and only we are taking design, code, and test. And therefore, here the DevOps culture has come up with new idea. So the DevOps culture is the same process. So here, design, they are going to come up with the design, and later again test, and again sorry code, and again test, and now after testing continuously they are going to deploy, and again we are going to take client requirements. If any requirement is changed, again we are going to design, and again we are going to code, and again we are going to test. So here a small change in the agile model is nothing but our DevOps culture. So here it is a recursive process. So with this, the deployment is not getting delayed, and the production environment is not taking much time. I mean, to get into the production environment, it is not taking much time. And the client is giving continuous requirements, and he is able to you make use of the application in a continuous way. So therefore, it is called continuous integration and continuous deploy, or continuous development culture, or I can use simply say DevOps culture. And earlier days, we used to take the deployment in the physical servers actually. So the physical servers, in the sense, a company used to have a big server, and in that particular server, they are going to deploy the applications, and using the IP address, they are going to access. And now every company is looking for the cost effective environment. So therefore, they have come up with clouds. So earlier we used to have physical servers, and later they have come up with virtual machines actually to utilize the resources effectively. And again, advanced versions of virtual machines, they have come up with containers. So now we are using containers, or we can say clouds, right? And also coming to the architecture, cloud architecture. So in the cloud architecture, uh, previously we used to have monolithic architecture. Here, monolithic architecture. So coming to the servers, so we used to have physical servers earlier days. And next, after the physical servers, they have come up with virtual machines. Next, now we are running with the containers. And coming to the architecture, cloud architecture. So here, now, cloud architecture, now we are using microservice architecture. Microservice architecture. So here, I can say current trend is here DevOps is continuous design, continuous code, continuous test, continuous deployment. That is called DevOps. And also containerization for making use of the resources effectively in the cloud environment. That is containerization. And also coming to the architecture part, microservice architecture. So this is what the current trend, right? So I'm using the word cloud. So what exactly the cloud is actually? The cloud is a new terminology for the people who are not aware of it. So here, usually to deploy the applications, we use the cloud, and the deployment happens in the container style. And we are going to build the applications in a microservice architecture. So usually the deployment may be in any cloud. Probably some companies are having their own clouds, big companies, and those who are not capable of establishing their own cloud architecture clouds, they're making use of the existing ones or the service oriented, that is service clouds like AWS, Azure, Google Cloud, DigitalOcean, and so on and so forth. But the DevOps culture is in all the clouds, the DevOps culture is same. That maybe one company may use AWS cloud, one company may use Microsoft Azure, one company may use Google Cloud. But as far as the DevOps culture is concerned, everything is same. The only thing is the architecture point of view or the way to develop the servers may be different in different cloud environments. But we are going to take the same procedure, continuous integration and continuous deployment. Design, code, test, deploy. Design, code, test, deploy. DCTD. So actually the motivation for DevOps. So here earlier we used to have, as I said, Agile waterfall model, agile model, and so on and so forth. But we have come up with the DevOps. So what is the motivation actually? For example, as I said, before the DevOps, let me take. We used to have developer team, right? And also for the testing, we used to have testing team. Let me take here like this. So for example, here we used to have developer team and testing team.
Yeah, Kiran, I have a small doubt in Agile and
Yeah,
DevOps
please.
model.
Yeah.
Yeah, the thing is, here you are showing us a design code and design code test in Agile model.
Yes.
And regarding deploy DevOps model, it is showing us design code test and deploy. So before deploy, what is the difference between the two? However, we'll be deploying that one and showing it to the customer in offline, in Agile model.
Yes, exactly.
And in DevOps, will be showing in online.
Yes, exactly. For example, let me take one example. For now, Christmas offer is there. Amazon site is there. For example, Amazon web application is already deployed and it is running properly. And now the client is coming up with Amazon client is coming up with a new offer, like say Christmas offer. He is giving 20% to all the products. So now he is giving that requirement. He is asking us to say, and it should be reflected in the application. So earlier, if I take the waterfall model, and whenever the client says, the developer has to write the code for the proper discount, and again the tester is going to test, and again is going to code and then test. And once the client is approved, for example, in the agile model, when the client approval is done, then we are going to deploy. And before the deploy, here, ultimately, once the customer's offer is enabled, for example, Amazon is running with 100 servers earlier. Before the customer's offer, Amazon is running with 100 servers. In the sense, in all the 100 servers, the same application is deployed. And based on the traffic, they have taken 100 servers. Now, once the customer's offer is enabled, usually the traffic is going to be increased and more customers will come and use the application. And definitely they have to purchase more servers. They have to, deploy the same application in more servers, say 200. So here, if I use that agile model, that is for increasing from 100 to 200. And once the client is, after testing part is done, once the client is coming up with the, the testing team is coming up with the result, operational team has to take the result from the tester and the requirement from the whole team, and then he has to put the request for increment in the servers. So it may take much time. Even the Christmas or New Year also may go, right? So therefore, here, to decrease the time gap, we are going to automate everything. The DevOps team is going to operate everything. Automate in the sense, here, whatever the application I have, the only part we are going to see is, based on the requirement, the developer will write the code and push the code in the repository. That's it. Just only the thing is, the developer will write the code and push the code. And everything, testing, deployment, and everything will be automated. Just it's a single click away. Single click away. So even on the deployment, based on the requirement, the number of servers may be escalated or after the offer, and ultimately here scale down. So here the scaling up and scaling down will be done automatically. So we are going to automate everything, and no need to, there is no manual intervention in this particular DevOps culture. That is the advantage here. So for example, on 24th night, 10 o'clock, the developer is giving the code for 20% offer. By 12 o'clock, the deployment is going to happen. But if you, with the case of Agile, if the developer is giving the code, let us say on 24th, it may get delayed by 27th or 28th, the deployment may happen. So here, that is the advantage with the DevOps. Everything is going to be automated. I'm going to show how the automation takes place. And at every stage, I'm going to explain how the automation takes place. So the only thing is, here in the DevOps, everything is automated except code development. So anyway, code development must be manually done. The developer should write the code.
Okay.
Yeah, actually, that is, I'm just giving some introduction part here. And once we are once we are aware of what is DevOps, then we'll go deep into that every part, every stage. So here, as I said, here we used to have earlier these many teams. So my intention is here, what is the action they are going to take and what is the automation is going to be happened. To make you aware of it, first you should know what exactly the purpose of developer team, what is the purpose of testing team, what is the purpose of operation team. Right, actually here, you may be aware of it. What is the role of developer team? Usually he is going to develop the code or write the code. And once it is done, he is going to test in the working environment. Maybe you are writing the code in your particular PC, and I'm writing the Java code. Let me say Java 9 is installed, and after writing the Java code, I am just testing it in my own PC by installing web server application, web server, Tomcat server, Tomcat 9. I'm going to test it, whether it is running in the web server properly or not. That is called unit testing. So here I'm going to test it. The developer is going to test it. And once the developer is satisfied, he is going to push the code into SCM. We call it as SCM. SCM in the sense source code management tool. So source code management tool in the sense we can also call it as version control management tool or version control system. In the sense there will be a central repository, or I can say central what you call directory. So here once the code is done and pushed to the source code management tool, now the testing team is going to take that or access that, and so we call it as checkout. Accessing in the sense checkout. The technical name is checkout. He's going to check out and he will do functional testing. So he may use any type of tool for the functional testing. For example, if you take automation, he may use Selenium, and he may use the functional test cases, maybe test cases written in the Zira. He'll write the test cases in the Zira and do the functional testing using automation. And he may use performance testing, and he is going to take performance testing. Once functional testing is done, the next part of the tester is performance testing. He may use load runner. So these are the softwares they used to use. They are using, even now they are using this, or JMeter. So lot many applications, lot many tools. Next, API testing. So these are the functionalities of a tester. You may use Postman for this API testing. So like this. So once the testing is done, testing in the sense, for example, after writing the code, 80% of the source code is running properly. I'm just putting benchmark, not 100%. Say 80% of the code is running properly, and only 20% of the code with some bugs. Yes, I'm just putting the benchmark 80%. So I'm going to deploy it. And if it is less than the benchmark, again it is going to be sent to the developer team, and they're going to modify the code and again deploy it. Again push it in the SCM, and again the testing team, and same process, blah 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 happens. And now coming to the operational team. And once the tester part is done and the code is ready for deployment, application is ready for deployment, and is going to provide or make the infrastructure available, and is going to take all the permissions and licenses and make the servers ready and then deploy. So these are the functionalities of each and every team in the earlier days. That is before the DevOps culture. So now in the DevOps, here the developer is not going to be replaced, and we are going to automate all these actions like testing and operations, and all the things will be automated using DevOps culture. So why? Because here earlier days, for example, the problem here is, as I said, the biggest motivation for the DevOps is ultimately the drawbacks in the previous one. Usually in the current in the industry, IT industry also, the new technology will come into the picture only if there is any necessity or if there any problem with the previous one, right? So here, for example, myself writing the code, I am the developer, I am developing the code and testing in my PC, and it is working properly, and it is running in my web server, say Tomcat. In Java 9 I am writing, and in Tomcat 9 I am testing. It is working. Next, QA team or testing team, quality assessment team is checking out the code from the repository, and it is running his own PC. The tester is running in his own PC, and it is tested and it is running successfully. But once it is deployed, it is not running. What may be the problem actually? That may be any issue like version compatibility. Version compatibility in the sense the developer is writing the code in Java 9, but in the operation while deploying in the production environment in the server, Java 8 is installed. That is older version is installed. So in the Java 9, we have more number of functions available, advanced version, but in the old version, that function is not available. Ultimately, it fails in the production environment. That may be a simple reason, or difference in the environment may be the reason, maybe the software platform. So these many reasons for failure. Why? Because here there is no synchronization between developer team, testing team, operation team. The developer team is developing the code in his own environment and is just pushing the code and just simply leaving. Tester is testing the code and just leaving. And next operational team is just deploying. And once there is any change, he is going to send it back. There is no synchronization between all the teams. And due to that, that is the time gap is more between design and deployment. Maybe any reason, maybe any reason. So therefore, they have come up with a question, whose mistake is that? Right? So therefore, these small issues may leads to much waste in the time. So therefore, we have to have an environment where all the teams must be under one umbrella. All the actions must be done in the same environment. So therefore, the DevOps culture has come into the picture. I think I hope you are following. Manish.
Yeah.
Yeah. Right. At any stage, the work may be delayed. So therefore, what we do is in the DevOps culture, we set up CI/CD pipeline to streamline the whole process. CI/CD, continuous integration and continuous deployment. And we are going to automate everything. Just it's a single click away. Single click away. Right? So we are going to establish CI/CD pipeline. Right? CI stands for continuous integration. CD stands for continuous deployment. CI/CD pipeline. So every industry now, in every industry, I mean, some industries, CI pipeline is different, CD pipeline is different, and in some industries, CI/CD pipeline is, I mean, together they are planning, they are developing. In some industries, they are developing CI and CD separate. I'll explain what is exactly CI, what exactly CD is. Right?
Yeah.
Now, yeah. Once the developer writes the code, as I said, he pushes the code to the repository. So the repository in the sense where we can have the access or we can store for time being. For time being. So here usually we have different repositories and the widely used one is GitHub. GitHub is the widely used one by most of the companies. By most of the companies, GitHub, and we do have Bitbucket, and so on. And some companies may have their own repositories, but widely used are GitHub and Bitbucket. So here the developer pushes into this repository. SCM, service source code management tool. So it is called source code management tool. Right? Now, the authentication, I mean, the automation should start from the testing part. As I said here, from here the automation should take place. So therefore, we are supposed to sync all the teams, and some automation must be done in all the teams. So now from GitHub, we need to create a pipeline. Please make use of the terminology and just remember the terminology. Pipeline. So we have to create a pipeline such that the production should happen in less time. So we need to create a pipeline. So only the developer will push the code into the GitHub and leave. We need should create a pipeline until the production happen in the less time. So that is what our motto, our goal, right? So here I'll show what is CI/CD pipeline. I am just taking one example. CI/CD architecture. Right?
Yeah, pipeline.
Example,
That means we will be pushing into GitHub, and for
Yeah.
Java, this will be using Maven, and for deploying, we'll be using Kubernetes, I think so.
Yes, exactly. Here we are no. From the GitHub, we are going to use CI tool, continuous integration tool. That is CI tool is not Maven, it is Jenkins. So most of the time, that is in most of the companies, they are using Jenkins. Yeah, and Jenkins makes use of Maven. So Maven is build tool. Jenkins is CI tool. Maven is build tool. With the Maven, it builds the code. And here for deployment, as you said, a Kubernetes cluster may be used. Now the current trend is Kubernetes. Yeah, here CI/CD, the first part is developer. First definition, a task is going to be defined. First task and next first task we are going to define. And next here to my system. Yeah. So here, once the task is defined by the client, assigned by the client, here, as I said, the developer is going to write the code. So coming to the developer functionalities here, the developer, as I said, make the environment ready. So here, make his PC ready with all the softwares. Next, here, pull the code. Here, pull the code in the sense in the repository already some code is available. Code from the GitHub, and here to access it and to his environment is going to check out from the Git. The action by the developer. He creates the branch. I'll explain what is branch exactly here. So here branch in the sense, for example, here in the repository in the GitHub, I'm just pushing the code. And every repository will have default branch, that is master branch. Master branch. So once you You are pulling the code and you are just saying checkout, and that code will be accessed by you and will be into your personal system. And again, in your personal system, you will be having personal repository, local repository. We call it as local repository. The code will come into local repository. And in the local repository, again, we'll be having the default master branch. So here, always the best way of writing the code is we should not disturb the code inside the master branch. So we need to create a branch, sub branch, and in the repository, whenever you create the branch, it will take the snapshot of the master branch. Snapshot in the sense the same image. Everything will be reflected into the branch. And whenever you write inside the branch, the master code will not be disturbed until and unless you say merge. Until and unless you say merge, right? So here we create a branch and we develop the code inside the branch. The developer will develop the code inside the branch and he will test. That is called unit test. Unit test. Once he is happy, he is going to push the code. Push to Git again. Push to Git. Yes, he is happy in the local repository. And after writing the code in the branch, and he is merging with his own master branch. And now he is ready to push the code into the again central repository, that is GitHub. GitHub. So again, he pushes the code to the Git and raises the pull request. And he raises the pull request. And here we need to accept it. The developer is, that is called PR. That is called PR. He raises the pull request, or I can say merge request, right? So now his part is over. Developer part is over. So now here comes our DevOps part. So here we have GitHub repository. I can say here it is. Let me say here it is GitHub. GitHub. So inside the GitHub, I have a master branch. So again in the master, again I have a sub branch. I can have sub branch. Any number of sub branches I can take, right? So it is a terminology of that particular repository, right? So here PR will be accepted once he pushes the code and raise the request. Pull request. Here that PR request will be accepted. Here he raised the pull request, right? And again here why? Because first of all is pulling the code from the repository. Therefore, two-way communication will be there from developer to GitHub and GitHub to developer, right? So now, and only up to this part, developer team will take place, or will take care of it. Now, our part is we have to create one service tool. Is nothing but Jenkins. It is Jenkins. Jenkins server, I can say. So it is nothing but CA tool, I can say. Or I can say that is right. So here the advantage with Jenkins is most of the companies are using the Jenkins. Why? Because here it is open source and written in Java, and that is why it is widely used. And it will monitor Git. So here it will monitor the Git. So whether any updates are available in the Git or not, or any pull requests are accepted by the Git or not. It is continuously monitors. So actually it is automated. Some automation is done already. So for the particular code, it is automated. So now the new request is coming from the client, new change is coming from the client, and therefore the developer is again pulling the code, previous code, and modifying it and pushing the code. And once the pull request is accepted by the gate, the Jenkins will stop automation. Why? Because it is continuously monitoring the gate, and once the new code is available, and it stops the automation, and again it will take the code from the GitHub. Right? So it is continuously monitoring. Right? So here the functionality of this Jenkins tool is it checkouts the project. As I said, from the Git repository, check out the project. And the task is here, compiles the code. Why? Because the code is available, right? Compiles the code. And next, before testing, he will do code coverage. So these are the functionalities of tester actually, functionalities of tester. And he will run unit test. Jenkins will run unit test. Everything is automated. And also code quality test, code quality. And then it is going to build. It is going to build the project code. Build in the sense, it is going to generate the web server understandable form, or nothing but a bundle. I can say a bundle. So that bundle may be, if it is a Java code, I can say jar file or var file, or if the developer is writing Python code, and in that particular format, that is going to be generated. Or I can say it is going to generate Docker image. It is going to build jar, var, or Docker image. And here, as you said, here it is going to use. Here it is going to use Maven, build a tool like Maven. Build tool like Maven. And once the building part is done, here he is going to move that. That is, we are done with the jar var Docker image, right? So we have that jar file. So that bundle should be moved to any artifactory here, right? Move the bundle to factory. Factory in the sense, it is a location where all the softwares are available actually here. And then it is just the task of tester. Everything is automated. And then after the function is done, we release the build. So once the build is released, you are ready to deploy, and it will deploy to the cluster. deploy to cluster. Yes. So these are the tasks by Jenkins. Everything is automated. We write the jobs for everything in the Jenkins. Now he is going to this is called this is called this is called continuous integration pipeline. It is called continuous integration or CI pipeline. Total thing is right. So here from here deployment is going to happen. It is going to deploy in the servers. So it is cloud. Cloud in the sense I can say server 1, 2, server 2, like that 100 servers. Here deployment takes place. So it is continuous deployment. From here to here, continuous deployment. So here this is complete CI/CD pipeline, and every stage from here after the GitHub, that is Jenkins cloud architecture design, everything must be done by DevOps engineer. And here, once the application is moved, for example, the application is developed and the Jenkins build is done and it is moved to production. It is moved to production, right? So we need to have some monitoring tools. As a part of the DevOps, we need to have some monitoring tools. Why? Because once the deployment is done, we need to monitor everything in the cloud. So here we can use the monitoring tools like Grafana, and we have a lot many tools. Most widely used one is Grafana, right? So here, what we are going to on the whole is here. Let me conclude here. Let me conclude. So here, one is continuous variable. Yes, development. We call it as simply. It can also be called as CD. Continuous development. That is by the developer. Here he uses the only thing Git. Right. And the second one is continuous testing. Yes, testing. I can say it as CI. Continuous integration, I can also say. Continuous integration. So for this, we are using the tools like Jenkins, Maven. We do have Gradle. We do have tools like Gradle or Nginx. So these many tools, different tools. However, we are not going to learn all these at this point of time. Just we'll learn what is Jenkins, how the Jenkins will do the automation, right? And also the other one is continuous deployment. Continuous deployment. It is CI/CD. The second and third one together is called CI/CD pipeline. Right here for continuous deployment, as I said, Kubernetes, or if the Docker image is built, I can use Docker into the Docker container. And the second one is, fourth one is continuous monitoring. It is shortly we can call it as CM. Right. So here, as I said, I can use Grafana, or I have Nagios, or I can have Splunk, or ELK. Lot many tools I have. And finally, cloud. Into the cloud, I'm just going to deploy, right? So I need to provide the infrastructure. So usually the DevOps earlier, DevOps engineer part is only up to the deployment part into the server part. But now we are also cloud architectures, right? You may be given the designation as cloud architecture, architect. Cloud architect in the sense you are supposed to develop the infrastructure, not manually. So you need to give some automation. Automation in the sense, and based on the requirement, you need to create the servers, and you need to write the code in such a way that based on the requirement, the server infrastructure will be developed. That is, with the code, you are going to provide the infrastructure. That is infra provisioning is another task here, maybe by the DevOps engineer nowadays. Right? For this, we use IAC tools. IAC stands for infrastructure as a code. So with the help of code, we are going to develop the infrastructure. And for this, we are going to use the tools like Ansible, Puppet, or Terraform. Right now, most widely used one is Terraform. It has huge requirement. So these are the tasks we are going to perform as a DevOps engineer. I hope you are following.
Yeah, but I didn't understand about IAC.
IAC stands for, okay, no problem. So for time being, you just remember that IAC stands for infrastructure as a code. With the help of code, we are going to develop the infrastructure in the cloud. For example, I'm saying server 1, server 2, server 3, like that I'm saying, no. And
Okay.
I have taken one example for Amazon, like based on the requirement, the number of servers must be increased from 100 to 200, right? And that automation must be done. Once the requirement is raised, and manually you are not supposed to increase the number of servers. The total number of servers must be increased automatically. And at the same time, once the application is changed, the previous application must be replaced. That automation must be done. Not only servers, apart from the servers in the cloud, you'd have lot many resources to be created. Not servers. I'll explain in a while time. When time comes, I'll explain Terraform, and I'm going to explain the coding part in the Terraform exclusive for AWS. How to develop the, create the infrastructure in the AWS. I'm going to explain at least the major part.
Yeah, one thing is Ansible and Terraform is the same procedure. That means if you want to
Purpose is same.
install a software in 200 servers at a time, we'll be writing code in one mission, and we'll be applying it to all the missions. In the same way, Terraform is also used.
Yes, exactly.
Yeah. Okay.
Yeah, Ansible is, these tools are called configuration management tools. We can also call as configuration management tool. We are managing the configuration. In the Ansible, we'll write playbooks in using AML code. In the Terraform, we write the code with the help of HCL, HashiCorp code language.
Okay.
Yeah. So we'll continue next class. With this, I'm winding up. If you have any doubts, you are most welcome.
Okay.
Yeah, and
can I get these videos?
Oh, you need this video. Actually, I just forgot to record it. Actually,
Somebody is recording, Naresh Reddy.
Okay, no problem. If anyone is recording, you can find it in your what you call meeting window, no issue.
Okay.
In your meeting
Yeah,
window, you can see. Yeah,
I
and
don't have the option to record here. Otherwise, I would have recorded. But there is no option showing for me as recording.
okay, I'll just go through it and I'll no problem. You can find it in your window.
Yeah, no issues, sir.
Yeah. And tomorrow, do you have any problem with timings from evening 5 to 6? Actually, I have a day shift, so I'll be more comfortable if I take from 5 to 6
Evening.
evening.
Yeah, no issues.
Okay, okay, no problem. I'll just send you a message in the WhatsApp. I'll be in touch. I'll take the number from Naresh. And,
Okay, okay then. Yeah, tomorrow at 5 to 6, evening?
yes, yes. Thank you.
Yeah,
Thank you.
no issues. Thank you. Thank you.